Alright, this is going to be a fun video because I'm going to show you guys two very fun facts with curl and also the divergence. The first one is that we are going to show the curl of del of little f is equal to the zero factor. So here we go. Firstly, I'm just going to do a quick review. Remember, f is our multivariable function, a scalar function technically, and when we do the del of f, it becomes a factor. So I will write this down for you guys. Del of f is equal to, you do the partial of f with respect to x, and then partial of f with respect to y, and then partial of f with respect to z. So definitely keep this in mind. But how do we do the curl? It's the del, do the cross product with this. So if we are looking at curl of del of f, by definition, again, this right here is what we have for the input, but for the curl, it's always going to be another del, and then you do the cross product with whichever this is. So we have this thing right here. Yeah. So how do we do it? Well, again, it will be the determinant. And here we once again have the 3×3 determinant. The top row is just the ijk unit vectors. And then for this del, it's the operators. So we have partial with respect to x, partial with respect to y, partial with respect to z. Lastly, for this, we'll be going to the third row, which are these right here. So we have partial of f with respect to x, partial of f with respect to y, partial of f with respect to z. And of course, right here, I should really mention that we will have to make sure that our little f and also the partial derivative, they are nice enough, continuous and all that stuff. But anyways, here we go. We are going to do the cofactor expansion. This, that, deleted, this times that. But when you multiply, it's really taking a partial derivative. Now, when you do this times that, it's d2f, right? Technically, the second derivative of f. I'm going to put it as partial y with respect to z. Partial y and then partial z, like this. In fact, water doesn't matter, so it doesn't really matter. So this and that, partial y, partial z, like so. And then we will have to subtract. Guess what? We do this and that, which becomes the second, like this, like a d, and then right here is f, and then once again I will do partial, technically partial z, partial y then. Okay, I will do that. So that's the first component, and then I. Next, expanded this, right? So this right here is the negative, keep that in mind. And then we do this times that, which is d2 partial f, and then I'll put on x and then z like this, minus this, that. So partial f2, and then z and x. And then j. Lastly, for the k, it's positive. And we have this and that, which is partial, the second partial, and then dx, dy. Technically, they are these. Actually, I don't know. This is what? This is not delta either, but anyways. Lastly, this and that. Partial, and then y. Yeah, and then this is the k component. Okay, guess what? This right here, 0. This right here, 0. This right here, 0. By Clairaut's theorem. So I'll just say, at the end, this right here is equal to our 0 factor, which I will just write it as 0, 0, 0. And now I will just say, by Clairaut. I might spell this wrong. Yeah, by Clairaut's theorem. Meaning the mixed partial are equal. It doesn't really matter like the order that you take the partial derivative. Yeah. So that. Okay. And in fact, if you think about it, whatever this thing is, if you look at this by itself as a vector field, this vector field is conservative. If you have a conservative vector field, then the curl of that will always be 0. Pretty cool, huh? Now, let's do another one. Now, for this one, we'll show that the divergence of the curl of the vector field f is equal to 0. But this is just a regular 0, it's not the 0 factor. For this right here, we'll do this inside out. So let's first review what the curl of f is. And you really have to know these notations really well. I do have another video going over the del, the curl, and also the divergence. Make sure you keep them in mind. Okay, this means what? We do the del notation, right? It's a factor, and we do the cross product because curl both start with C, and then here is the vector field f. Okay. All right. Now, do I really want to write down the expression for this? Okay, I will do just that. In fact, this right here, you have an expression, and it's just going to be, depending if you want to remember that, we'll just like do this again, kind of like up to you. But in this case, I'm going to write this right here, which is partial with respect to x, partial with respect to y. Remember, these are the operators. And then the f, I'm just going to say f, I'm going to write it as p, q, r. So for the f, I'm just going to put down p, q, r. Now we just have to work this out. So I will delete this, delete that, do the this times that. So partial r with respect to y, and then minus this and that. So it's partial q with respect to z. So that's my first component. Continue for the j, it's a minus. So keep that in mind. And then we will have this and that. So it's partial r, partial x. This and that is partial p, partial z. And subtract, of course. And then, lastly, we have the k. And we do this and that. So it's partial q with respect to x minus partial p with respect to y. And that's the k component. Good. Now, we're doing the divergence of this thing. And of course, this is the factor. So here we go. Divergence of the curl of f. So here is what we have to remember. The del notation, I'll put this down just to see again. So now what do we do? For the divergence, we are doing the what? Divergence towards the d, so it's a dot product. Dot product with the curl. So I will just write this down. So now I'm just going to do this times this. Now this is just to take the partial derivative. So we will have partial square r, and then I'm going to do that right here, partial x, partial y, and then so we have minus partial square q, partial x, partial z. Now minus, why is this blue? Minus, and then partial square r, partial y, partial x. Minus becomes a plus, be careful with that, and then partial y, partial z on the bottom. Partial y, partial z. And then do this, so plus partial 2q, partial z, partial x, minus partial whatever, and then partial whatever. It's a lot of fun, but just make sure you don't make any careless mistakes. So now, here's the deal. Remember the order of the denominator, right? This and that, the order doesn't matter because of the clear-out theorem. So now we just have to see, have a look. Here we have the partial 2q and partial 2q, partial x, partial z. So this and that cancel, yeah, because they are equal. And then for the r, this and that will also be equal, so I'm just going to cross it out twice to show you that I'm crossing out this with that. And lastly, with the p, this right here. So all in all, we just get 0. Pretty fun in my opinion. Yeah, that's it.